All right, my friends, today we're going to be talking about things that are called parallel and perpendicular lines. This should sound familiar because you learned a little bit about them last year in 8th grade. But what we're going to be doing today is eventually writing equations of parallel lines and writing equations of perpendicular lines. I have up on the screen Desmos today because we're going to be using Desmos a lot to visually see what parallel and perpendicular lines actually look like on graphs because it's a very visual concept. Okay, when we're talking about parallel lines are two lines that will never intersect. Since these two lines will never intersect, here's an example of them on the graph there. They have the same slope, and that's the number one takeaway we need today about parallel lines is that they have the same slope. They go the same direction. They have the same incline, which means they will never cross each other. They do, however, have different y-intercepts, just so that they're different lines. So parallel lines look like that, where they're never going to intersect on that graph, and they have the same exact slopes. Perpendicular lines, however, are a little bit different. If you notice on the graph here, you have a pair of perpendicular lines. Hopefully you notice that these look like they meet at a right angle. And that is exactly right. Perpendicular lines are two lines that intersect at a perfect 90-degree angle. Okay, they create a 90-degree angle or a right angle whenever they cross. What we need to know about perpendicular lines when we talk about their slopes is that the product of their slopes is -1, which is called opposite reciprocals. Now, those are some big words you probably have not seen that much before. When I'm talking about opposite things, I'm talking about opposite signs. So what we're going to do to create a perpendicular slope is we are going to change the sign. That's the opposite part. And reciprocal has to do with fractions, and it's when we flip the fraction. So we're going to change the sign, and we're going to flip the fraction, and we'll have created an opposite reciprocal. If we multiplied these things together, there would be -1. But what we need to know is how to write or create opposite reciprocals. Flip the fraction, change the sign. So an example of an opposite reciprocal, if I gave you 1/2 and asked you for the opposite reciprocal, the opposite of +1/2 is definitely negative, and then just flip that fraction. -2/1 or just a -2. The opposite reciprocal of -5/3, well, the opposite of negative is positive, and the flip fraction would be 3/5. What is the opposite reciprocal of 4? Sorry, -4. Hint, -4 is -4/1. What is the opposite reciprocal? 1/4. Very good. Flip the fraction, change the sign. And since 1 is also like saying 1/1, what is the opposite reciprocal? -1/1. Fantastic. Now what we're going to do to determine if these lines are parallel, perpendicular, or neither is we're going to try this by looking at their slopes, and we're going to check in Desmos to make sure we know visually what it means for things to be parallel, perpendicular, or neither. So if we look at number 1, let's highlight the slopes in number 1. So the slope in the first one, first equation, y equals 4x plus 5 is 4. And the second one, it also has a slope of 4, which means that these two lines, since their slopes are both 4, is going to be parallel. Now I'm going to use the shorthand for parallel because y'all know I'm lazy. When I'm talking about parallel, I'm just going to draw two straight up and down parallel lines. Let's look at number 2. Number 2, the slope of the first part of number 2 is -6 because that's where the m goes. And the second part is written in point slope form. Do you remember which one of those numbers represents my slope? Yeah, 1/6 represents my slope here. That's where the m goes in point slope form. So you look at these two slopes, -6 and 1/6. These two slopes are opposite reciprocals. They're flip and flip, which means that these are perpendicular. And that's the shorthand for perpendicular. So it looks like a perpendicular line. Parallel, perpendicular. Now, if we look at number 3, we can tell the slope of the first part really easy. That slope is 2. Easy. Check. But number 3, that's in standard form. We're going to have to solve for y to be able to tell you the slope. So we're going to move the 2x to the other side, crosses the line. It's going to change the sign. That means my equation is actually y equals 2x minus 15. And therefore, my slope is 2. What is it called when they have the same slope? Parallel. Very good. Number 4, here are the slopes. These are already solved for y, so we know our slopes are going to be -3 and -1/3. Are these parallel, perpendicular, or neither? Yeah, hopefully you notice that these are neither. They're not the same, obviously, and they're not flip and flip. They're not opposite signs, though they are flipped fractions. This would be neither. You've got number 5 and 6 on your own. Try to see if you can tell if these are parallel, perpendicular, or neither. Hopefully you notice that on number 5, the slopes of -2 and +1/2 are opposite reciprocals, opposite signs, flipped fraction. That means these are perpendicular. Number 6 is challenging. Did you guys recognize that this one, y equal -3, is a Hoy function, so its slope is 0, and that this one is a Vux function, which means that its slope is undefined? Well, 0 is flat, and undefined is straight up and down. And so those two things would meet at a right angle. That makes them perpendicular. But let's just say we were super confused about this and we wanted a way to check our work. We are going to use Desmos to do that. I'm going to check all 6 of them with you now to make sure we visually can tell that that's what these are. The first set of equations we had was y equals 4x plus 5 and y equals 4x minus 13. Do you see visually that these equations, no matter how much I zoom out or move around on this graph, are never going to intersect? That means that they are parallel, which is exactly what we wrote down, the pair of L's. Now for number 2, we check that one to make sure we can tell that they're perpendicular. Y equals -6x minus 8 and y minus 8 equal to 1/6 parentheses x minus 12. Do you see that these visually meet at that right angle? They're perpendicular. Okay, the next one we had y equals 2x plus 8, and we solved for y to have the equation y equals 2x minus 15. We said that these were parallel because they had the same slope, and that is true. Look, they never intersect no matter how much I zoom out. We check number 4. The fourth equation that we had was y equals -3x plus 5 and y equals -1/3 x plus 17. Now I have to kind of find this one. It kind of went off the graph, so I'm going to go find it. You can tell right away that these are obviously not parallel because they intersect, and that this is not a right angle. So these are neither parallel or perpendicular. They're just some lines. Number 5, we had y equals -2x plus 4 and y equals 1/2 x minus 1. And we can see very easily that these meet at a perfect right angle. That makes them perpendicular. Last but not least, we had our Hoy and Vux equations of y equals -3 and x equals -3. There are vertical and horizontal lines here, and they meet at a perfect right angle. So if you are confused on whether something is parallel, perpendicular, or neither, just remember you can always toss it into Desmos because we visually can see when things are parallel, perpendicular, or neither. All right, let's flip to the inside of our notes here. Here is the real meat of the lesson. We not only want to be able to tell when things are parallel and perpendicular, we want to be able to write equations of parallel lines. So here are the steps. When it asks you to write an equation of a line in slope-intercept form, y equals mx plus b, that passes through a point and is parallel to a given line, you're going to do the following. Find the slope. Plug the slope and the point into point-slope form because you want the same slope. And then rearrange to slope-intercept form and check it in Desmos. Let's check out number 7 together. You guys will try number 8. So if we label all of our stuff, this is going to be x1 and y1, and we need a slope that's parallel to that line. Well, parallel means the same slope. So I'm just going to gather this slope of 1/3, and I'm going to use that. If I have a point and a slope, I'm going to use point-slope form. Y minus y1 equal to m x minus x1. Yes, I know that's a lot of writing, but I want you to write it down so that you know what equation you're filling in when you have a point and a slope. All right, just like last time, you're going to take your slope and you're going to plug it in for m. You're going to take your x1 and you're going to plug it in for x1. You're going to take your y1 and you're going to plug it in for y1. Easy peasy, just as you are. So we have y minus y1, so that's y minus -1, equal to 1/3 x minus 3. Now the double negatives bother us here, so we're going to go ahead and rewrite this equation, simplifying to a positive. If it had asked me to stop at point slope, I'd be done. But it asked me for this equation to be written in slope-intercept form. 2 extra steps. We're going to distribute. 1/3 times x is 1/3 x. 1/3 times -3, check it in a calculator if you don't believe me, is 1. -1, sorry. And then we have y plus 1. The last step is just to take this plus 1 and move it to the other side. When it crosses the line, it changes the sign, and we can combine those constants together. This should sound familiar. We did this last class when we were writing things in point-slope form. And voila. Here's what I think the equation will be if I write it in Desmos of the line that is parallel to this one and goes through this point. So let's just make sure we're right. We type everything into Desmos. Here's the coordinate point we wanted it to be 3, 1, -1. I'm going to let it be labeled so you can see it. That's the point we want our line to go through, and we want our line to be parallel to y equals 1/3 x minus 3. Now we think that the equation y equals 1/3 x minus 2 is going to do it. Does it visually go through the point, and is it parallel to the purple line that we started with? Yeah, it crosses through the point and it's parallel. We did it right. We can visually check our work. Now it's your turn. These steps are very simple. They're written at the top of your screen. I want you to stop, pause the video, try number 8, and see if it works whenever you throw it into Desmos and check your work. So here's my work. We want to check it with yours. Did you plug in x1, y1, and the same slope from that equation into point-slope form and rearrange to get it in slope-intercept form? If you did that, you should have gotten y equals 7/2x plus 2. And we checked that in Desmos to make sure it visually makes sense. And it does. Here's our coordinate point that we want it to cross through, 0, 2, and we want it to be parallel to this blue line. Our equation that we wrote is the green one. Does it go through that point, and is it parallel to the blue line? Yes. Visually, this makes sense. We have the correct equation. It fits the boundaries that we were given. Goes through that point and is parallel to that line. Awesome. Now, the only way that we can make this question harder is things like number 9 and 10. But these aren't way out of our league. If you look at number 9, we still want to write an equation that is parallel to 2x plus y equal 1 and goes through the coordinate point 1, -2. So here's what I know. I know that they've already given us an x1 and a y1. But have they given us explicitly the slope? No, this is written in standard form. In standard form, we can't see the slope right away, but we know how to get things written into slope-intercept form. So we're going to do that really quickly. We're going to cross a line and change the sign. We'll have y equal to -2x plus 1. Technically, there's a 1 in front of y right now, but it's positive, which means I'm actually done solving for y. At this point, I have x1, I have y1, and I have my slope. I used the wrong color. Here's y1, and I have the slope that I want to use, and I need it to be the same slope. Cool. Let's follow the same steps we did before. we take point slope form, since we have a point and a slope, and we're going to fill in the points. This would be y minus y1, which is negative 2, equal to m, negative 2, x minus x1. We fix the double negatives because that doesn't make any sense, and we change it to a plus. And now all we have to do to write it in slope-intercept form is quickly distribute and then move the positive 2 to the other side. Crossing the line, we change the sign. Positive 2 and negative 2 will eliminate, and so our equation that we think is right is y equals negative 2x. But of course, let's visually make sure that it makes sense in Desmos. Okay, so let's see. We want our line to go through the coordinate point 1, negative 2. Let's label it. We also want it to be parallel to 2x plus y equal to 1. We'll go ahead and graph this in standard form just so we can make sure it looks right. And we think our line is y equals negative 2x. Does the line that we wrote, the red one, go through the coordinate point, and is it parallel to that line? Awesome. It looks visually right, which means we did it. Congratulations. Okay, on number 10, it's actually almost easier because they've given you the graph here. You just need to figure out what the slope of that line is and what the equation is that goes through that red coordinate point and uses the same slope. Okay, well, we know how to do this. Let's count our slopes. To get from the first point to the second point, since I need a point and a slope, I had to go up 4 and to the right 2. Which means that my slope is going to be a rise of 4 and a run of 2. My slope is 2 over 1, or 2. Well, now I have x1 and y1, and I have a slope. When I have a point and a slope, I'm going to use point-slope form. We fill everything in that we know. We know that the y is going to be negative 3. We know that the slope is 2, and that the x is going to be negative 3. We fix both of the double negatives because that's just confusing. Y plus 3 equal to 2 times x plus 3. Much prettier. And since we want this in slope-intercept form, we're going to distribute 2x plus 6 and then move the positive 3, crossing the line, changing the sign. We think that 2x plus 3 is going to be the equation that is parallel to the blue line and goes through the coordinate points negative 3, negative 3. Cool. So let's try it. We know that from that coordinate point, it should have a slope of 2. So we're going to go up 2 units, 1, 2, and over 1. If I connect the dots on those with a straight edge, as straight as possible, you can still laugh at my inability to draw straight lines. I'm literally using a ruler and it's still not straight, but y'all get it. If I had drawn that actually straight, you would know that these are parallel lines. They will never intersect, especially when they're drawn by somebody better than me, and that they go through that coordinate point. So visually, this sort of stuff makes sense. Okay? The same problems, or the problems are going to work very similarly when I ask you to do this for perpendicular lines. Except that when I'm using perpendicular lines, we're not going to use the exact same slope. We're going to use slopes that are opposite reciprocals. What did opposite reciprocal mean? Opposite reciprocal means that we change the sign and we flip the fraction. Okay, so let me walk you through the first one. The steps are all the same other than that. In the first one, we have that the coordinates are x1 and y1, and that I have a slope originally of 2/3, but I want it to be perpendicular. So the slope that I'm going to use, the perpendicular slope, is going to be the opposite sign and the flipped fraction. I'm going to use negative 3 over 2. And now I have a slope, I have an x1, and I have a y1. That's everything I had a second ago when I was doing the same kind of problem. If we have a point and a slope, we fill in point-slope form. Y minus y1 equal to m times x minus x1. All of those parts are labeled. We just put them where they belong. Y minus 2 equal to negative 3 over 2, x minus negative 2. And then I'm going to clean up those double negatives just because I don't need that kind of negativity in my life. It's a joke. And then to finish putting it in slope-intercept form, we're going to distribute negative 3 over 2x plus 2, 3, nope, negative 3. And then we're going to bring that negative 2 over, crossing the line, we're going to change the sign. So we think that y equals negative 3 over 2x minus 1, negative 3 plus 2 is minus 1, is the equation that when graphed will go through the coordinate point negative 2, 2, and will be perpendicular to that original line. So let's visually check and make sure. Here's my coordinate of negative 2, comma 2. And our original line is y equals 2/3 x plus 2. We think that the line y equals negative 3 over 2x minus 1 is going to go through that coordinate point and hit the black line at a right angle. Boom. Looks like a right angle to me. These are perpendicular, and it goes through the coordinate point negative 2, comma 2. Fantastic. Okay, pause the video. I want you to try number 12. Please write for me an equation that passes through that coordinate point and is perpendicular to that equation. So here's what I got, and I got this by taking the opposite reciprocal slope, which means not 7 over 2, but 2 over 7. Flip the fraction, change the sign. That's the slope that I'm going to use since it's perpendicular. I also used the y1 and the x1 that were given to me, and I plugged them in exactly where they belong. Okay. There was no double negatives to take care of, and then we distributed to rewrite it into slope-intercept form. Here's Desmos so I can visually tell that I got this right. Here's my coordinate point and the original line. If I turn this line on and it goes through that coordinate point and looks perpendicular, which means it meets at a right angle, we did it right. Woohoo! Fantastic. I'm going to let you guys try number 13 because I feel like we need to have more independent practice on this. So number 13 is yours. I want you to find the original slope because it's not shown to you yet. Flip and flip, find the opposite reciprocal, and then do the same process so that you can write an equation that is perpendicular to that line and passes through that point. Check it out. How'd you do? Did you get y equals 1/2 x minus 1? Hopefully you realize that we were going to have to solve for a y by dividing by negative 2 for each of those terms of the original equation to find the slope. The original slope was negative 2, which means that the slope that I want to use, the perpendicular slope, is the flipped version of 2, 1 over 2, and the opposite sign, so a positive number. We also had the x1 and the y1 given to us in the original equation, which we're just going to pop into our point slope form. We distribute, we rearrange, we have slope-intercept form, and we can visually check our work. Here's the original line graphed implicitly, and here is our coordinate point. When I turn this on, if it looks perpendicular, meaning at a right angle, and it goes through that coordinate point, we're good to go. Fantastic. This last one, number 14, is also for you. I want you to go ahead and graph it on here whenever you finish. Find the slope, then write the perpendicular line that goes through that coordinate point. So here's what I got, and I know this one was wild because you were left with a fraction as your y-intercept, and that's going to happen. Fractions are your friends. Please leave it as a fraction, not a decimal. Okay, so what we did, or what we should have done first, is found our slope of the blue line by counting up 3 and over 2. That's the original slope, which means the slope I want to use to make it perpendicular is the opposite reciprocal. Change the sign, flip the fraction. But now I have a point and I have a slope. We fill it into point slope form. So useful. We fill it in like it's supposed to, get rid of our double negatives. Then we distribute, and yes, we leave it as fractions. We still move things over, still leave it as fractions. You have a calculator to help you out. And we'll get y equals negative 2/3 x plus 4/3. Now, to make sure this makes sense, we know that it should go through that coordinate point and have a slope of -2/3. So from that coordinate point, if I go down 2 and to the right 3, I would hit that coordinate point right there and draw my straight line. That's not drawing a straight line. And draw my straight line in between them. Those meet at a right angle, which means I have made perpendicular lines. Can use Desmos to check your work on this as well. So the main gist that I need us to know today is how to visually tell the difference between parallel and perpendicular lines. So that goes back to these graphics right here. These graphics are super important because parallel lines will look like they would never intersect. And perpendicular lines with their opposite reciprocal slopes meet at a right angle or 90 degrees. That's the gist of today. Thanks for hanging in for this a little bit longer video. See you guys in class.